Hello everybody, and we're going to be taking a look at linear functions, specifically algebraic manipulation and the general form. So, if we're given a linear function in the form cx plus dy is equal to e, remember that c, d, and e are just any real numbers. So c and d are coefficients of x and y respectively, and e is just any real number that's acting as a constant. So we want to know what methods can we use to find the slope, the x-intercept, and the y-intercept. So let's take a look at a general equation. Oops. Let's take a look at a general form equation. Oh, that is not maximizing. There we go. So we've got 5x minus 3y is equal to negative 2. Now, recall that the x-intercept occurs when y is equal to 0, and the y-intercept occurs when x equals 0. So when we're looking at general form, we're going to use a table of values. So we want to find out the x and y intercepts, and that's the first thing we can find out. So remember, your y-intercept occurs when x is equal to 0, and your x-intercept occurs when y is equal to 0. So what I want you to do now is you're going to use substitution, 0 in for x to find the y-intercept, and 0 in for y to find the x-intercept. All right, so let's take a look here. So when x is 0, yes, you are a rapscallion. When x is 0, and that's not a wrapping scallion, that's different. When x is equal to 0, we get the equation negative 3y is equal to negative 2. So what we have to do to both sides is we divide both sides by negative 3. So that gives us a y-intercept of 2 over 3, positive 2 over 3. Yeah, that's all you got to do. Well, what's a negative divided by a negative? Positive, right? So remember, two negatives multiplied or divided together will cancel out to give you a positive. So similarly here, we divide both sides by 5. And because there's only one negative sign, it'll stay negative. So this is negative 2 over 5. Okay? So we get a y-intercept of 2/3, an x-intercept of negative 2/5. So now we can see this is a really fast calculation. That's one of the things that the general form does really well. It's super efficient at finding the x and y intercepts. So from this equation, how can we find out what the slope is? So we can actually use this table of values we just created to find delta x and delta y. So we had 0, 2 over 3. And we had negative 2 over 5, 0. So remember that our slope is equal to the change in y over the change in x. So as long as we're going in the same direction, we just have to look at the changes that are taking place. So am I going too fast? Are we going okay? Okay. So if I jump from 0 to negative 2/5, what's my change? Yeah, negative 2/5. So now, this one's a little bit more tricky. If I jump from 2/3 to 0, what's my change? Negative 2/3, because if I start at 2/3, how do I get to 0? I take away 2/3. Okay? And this is your delta x, your change in x. And this is your change in y. So now we just have to divide these two. So I have negative 2 over 3 divided by negative 2 over, ooh, what's going on here, computer? Oh, close program. No, let's not do that, please. Please don't. No, you're going to, no. No.
What's happening?
I don't know what's happening. I'm just going to keep drawing and we'll see if it decides to shut us down. Oh, no. Yeah. So that's the fun of broadcasting live to the internet when you're using a computer that's 5 years old. Okay, so we got our division here. Now remember, how we divide fractions is your numerator stays the same, and you multiply by the reciprocal of your denominator. So the reciprocal of your denominator is negative 5 over 2. And the nice thing about multiplying fractions, tops multiply tops, bottoms multiply bottoms. So I get 10 over 6. And this will simplify to 5 over 3.
How do we multiply? Is the reciprocal
Yeah, multiply by the reciprocal of the denominator. Yeah, you got it. You got it. And then when you're multiplying fractions, the top multiplies the top, the bottom multiplies the bottom.
Would it be no?
Because think about that, right? Because negative times a negative is a positive. And the way you can think of it is, think about the word of, right? So like multiplication can often be replaced with the word of. So a negative of a negative is positive, right? What's the opposite of a negative? Positive. And you also think like a negative times a positive. Well, what's negative of positive? It's negative. So let's take a look at what we've got here. So how can we use the x-intercept, y-intercept, and slope to convert this linear function into slope-intercept form? So for slope-intercept form, we need the slope, and we need our y-intercept. What value did we have for our y-intercept? So take a look back. Our y-intercept was 2/3, right? So now, what would this be in the form of y equals mx plus b? What equation would I have? Y is equal to what? So 5/3 x plus 2/3. And there we go. So this is the exact same linear function, but now it's in a different form. Sorry. So what we want to do now is there a way that we can check our answer using algebraic manipulation? And thankfully that answer is yes, we can. Because algebra is amazing. It's like the best thing ever. I'm just going to scroll up. Ooh, what's going on here, computer? You're not liking what I'm putting here. Okay. Can I go on to the next one, or do people need to still copy some stuff down? Can I move on? Okay. So let's take a look here. I want to see if I can change y is equal to 5/3x plus 2/3, if I can change this into our original of 5x minus 3y equals -2. So 5x minus 3y equals -2. So I want to see, okay, can this be done? And can I easily go from one to the other without having to do all that in-between process? The answer is yes. So first, I'm going to use this direction. Okay? We're going to go from standard form back into general form first. So I need to do something to this guy. So the first thing I notice is that on the right here, none of these have denominators. So what do I do to clear a denominator? What's my step? So I multiply by the denominator. So to clear out a denominator, you multiply by the common denominator. In case here, there's only a single denominator of 3, so I just multiply both sides by 3. And if it helps to think of it, you can think of 3 as 3/1. So 3 times y gives me 3y. And now 3 times 5/3 is just 5. And 3 times 2/3 is just 2. Okay? So now, what's the difference between this guy and this guy? Well, on this one, the x's and y's are both on the same side. So what can I do to get rid of this 5x? I need to get rid of this entire term. What could I do to get rid of it? Well, remember, to get rid of an entire term, you add or subtract. Yeah, I'm going to take away 5x. And that's an important thing to remember. So to get rid of entire terms, you either add them or subtract them. To get rid of coefficients or variables that are attached, that's when we use division. So that's where the different ones come into play. So here, this is going to leave me with 3y minus 5x is equal to positive 2. Now, what's the difference between these two? I need to have a negative. So what I'm allowed to do is, remember, you're allowed to multiply both sides by anything, as long as it's not 0. Can't multiply both sides by 0 because that leaves everything useless. But I can multiply everything by -1. You can multiply both sides by 0, but then you just get, hey, 0 is the same as 0, and we try to avoid that. So I can change the sign of everything, and I can get negative 3y plus 5x is equal to negative 2. And now we can see that our terms exactly match up. Here I've got a negative 2. Here I've got a negative 2. Here I have positive 5x. No, remember, the order of addition and subtraction never matters. So for instance, like 4 take away, or 4 plus negative 3 is the same as negative 3 plus 4. Same with multiplication. The order of multiplication never matters. And here I have a negative 3y and a negative 3y. So here I've shown that I can change from standard form into general form only in a few steps. So what we're going to do next is we're going to do the opposite direction. I'm going to take my general form equation and I'm going to change it into standard form using only algebraic manipulation. So notice that in standard form, the y is by itself. So what we want to do is we want to isolate the y. So the first thing I want to do is I want to get rid of this term here, the 5x. So what do I have to do to both sides to get rid of that entire term? Subtract. Because it's to get rid of an entire term, we use subtraction, or addition if it's a negative. So we're going to get the following. So I'm going to have negative 3y left on the left-hand side, and I'm going to have negative 5x take away 2. Okay. So now, the next thing I have to get rid of, we need y completely by itself. So I need to get rid of a coefficient of 3. So to get rid of a coefficient, what do? Yeah, we use division. So I'm going to divide both sides by my coefficient of negative 3. So that means everything here, not just the x term and not just the constant term, but both of them need to be divided by negative 3. Okay? So that's going to leave me with just a y over here. Let's draw a dividing line. So now negative 5 divided by negative 3 is just the fraction 5 over 3. So I get 5 over 3x. And negative 2 divided by negative 3 is just the fraction 2 over 3. So there we see that we have a number of ways to go between two different types. If I'm going between general form and standard form, I can use algebraic manipulation, or I can kind of use a data collection process, right? So both methods are useful. Lexi, please.
On the test, are we gonna have to do both of these, or can we pick one?
On the final exam and the test, you may be asked to specifically do both. More specifically, the types of question you might have is, hey, someone did this, can you find the errors? So kind of doing an error analysis. Yeah. In most general cases, you will be able to use whichever one you like best, but there may be specific cases of error analysis where you'll have to understand both. But very good question. Thank you. Okay, any other questions with this? Okay, so let's take a look at our next page. So let's just flip the sheet over here. So now we're going to practice this converting between forms. So how can we show that two linear functions in different forms are indeed the same? So we've got y is equal to negative 7 over 9x plus 14 over 3, and 7x plus 9y is equal to 42. So we want to show whether or not these two are equal or if they're different. So the first thing we're going to do is we're going to practice converting from standard form into general form. So our first step is we need to identify our common denominator. So if I have the denominator of 9 and 3, we need to find out what's the lowest common multiple. So thinking back to our unit on LCM, the lowest common multiple of 9 and 3 is 9. So we multiply both sides by 9. And if it helps to think of it this way, you can think of it as 9 over 1. So what will this give us? So from here, I'm going to have 9y is equal to negative 7x plus, so think about this. One way to multiply fractions, and we'll just do a little aside here, is to use reduce before you multiply. Okay? So if you're having a little bit of trouble with the fractions here. So think about this. You can always simplify fractions tops and bottoms. And we can even do it before we multiply. So is 9 divisible by 3? Yeah. So what's 9 divided by 3? 3. What's 3 divided by 3? 1. So now this is the same as just 3 times 14, which gives you 42. So that's how you can kind of quickly do these fraction multiplications. Okay. So now the next step that I need to do is I need to bring this x term over. So I'm going to do that by adding 7x to both sides. And remember, x's and y's don't add together. They're not like objects. So this is going to give me 9y plus 7x is equal to 42. So are these two indeed equal? Yeah, exactly, because remember, the order of multiplication does not matter, nor does the order of addition matter. So this is exactly the same as this, and they're both equal to positive 42. Okay? So we've just shown that these two, by algebraic manipulation, are indeed the exact same linear equations. So now, let's practice doing the opposite. So I want you to convert 7x plus 9y equals 42 into standard form. All right, so our first step here is we want to get, our whole goal is to get this y by itself. So the first thing I want to do is I'm going to take away 7x from both sides. So I subtract 7x on both the left and the right. So I'm going to be left with 9y is equal to negative 7x plus 42. So my next step is I need to get rid of the coefficient. So I have to divide everything on this side by 9. So what I'm going to get is y is equal to the fraction negative 7 over 9x. And 42 over 9 simplifies to 14 over 3. So are these two once again equal? You betcha. So I get a slope of negative 7 over 9, a slope of negative 7 over 9, and a y-intercept of 14 over 3, and a y-intercept of 14 over 3. So being able to convert between these two forms quickly is useful because each form specializes in something. Okay? The better your algebra skills, the faster you're going to be able to pull the information out no matter what. So I want to take a look at one of the questions in your workbook here. I want to take a look at number 6. So if you can take a page of 574, and we're going to take a look at question number 6. So we get the following. We're given two linear equations. X minus 2y plus 1 is equal to 0. And 3x minus 2y plus 5 is equal to 0. Oops, sorry, no, I'm reading the wrong one. My apologies. That's number 5. So I've got x minus 2y plus 1 is equal to 0. And then for my other one, we have a variable k hiding out. So it's 4x plus k times y minus 8 is equal to 0. So we're asked to do the following. We want to determine the value of k so that these two lines have the exact same slope. Next, we want to determine the value of k so that these two lines have the exact same y-intercept. So what would be the most efficient way to solve this problem? What form has both slope and y-intercept readily available to us? The slope-intercept form. Right? So we're going to need to convert both of these into the form y is equal to mx plus b. Okay? So I want you right now to convert both of these linear equations into our standard form, y equals mx plus b. All right, so let's take a look here. I need to get rid of this term. Really, that's what I need to do, right? I don't need to get rid of the x and the 1. It'd be much faster just to isolate this term. So kind of the quick way to do it is I'm just going to move the y, and that way it'll be on its own side. So, yeah, so I can add 2y to both sides on this one. For here, what I can do is I can take away k times y on this one. So let's see what we end up getting. For here, I'm going to get x plus 1 is equal to 2 times y. And for here, I'm going to get 4x minus 8 is equal to negative k times y. So now in each case, what I have to do is divide out our coefficient. So on the left here, I'm going to divide everything over here by 2. And on the right here, I'm going to divide everything by negative k. And now we're going to simplify. So simplifying, I can rearrange, I can just move the x and y over if I want, but I'll just leave it for now. I get a half x plus a half is equal to y. And on the right, in blue, I get negative 4 over k x plus 8 over k is equal to y. Now what we need is I need, first of all, the value of k that makes both the slopes equal. So that's our first question for part A. What value of k makes both our slopes equal? So what's our slope for our linear function on the left? Yeah, 1 over 2. So I've got a slope of 1 over 2 has to be equal to, and what's our slope for this guy on the right? Well, it's negative 4 over k. Okay? So I need to find a value of k that makes 1 over 2 equal to negative 4 over k. There you go, negative 8. Okay, because it has to be negative, right? And then think about our ratios here. So if you're having trouble seeing this, what you can think of is what's in our denominators. Okay, what's your common denominator? Common denominator as well, in our denominators we have both 2 and k. So the common denominator is then 2 times k. So I'm going to multiply both sides by 2k over 1. And then we just simplify. So I'm going to get, the left-hand side simplifies to k is equal to, and I have the right-hand side simplifying to negative 8. So when the value of k is negative 8, both of my linear functions will have exactly the same slope. So that's for A. For B, we're asked about our y-intercepts. Okay? So what's the y-intercept of this guy on the left? Yeah, 1 over 2. So has a y-intercept of 1 over 2. What's the y-intercept of this guy? No, 8 over k. That's just a k, right? 8 over k. Because remember, this is your y-intercept, the adding of the constant term. So what I need is for both of these to be equal. So 1 over 2 is equal to 8 over k. So you said the answer, like what it actually is, right? So you saw very quickly that k is 16. If you're having trouble seeing that k is equal to 16, then we can use algebra to help us out. We're going to use the exact same process. Here, my common denominator is 2k, so I'm going to multiply both sides by my common denominator of 2k. And I'm going to be left with k is equal to 16. Okay, and that's about the hardest type of question that we're going to be seeing, involving converting between general and standard forms. So any question with that one? Okay, so let's take a look at our assignment.